That's a good question.
Why are we going to get our Star Trek on? Well, basically, it's we're going to go where no chem has gone before.
On a date?
Yeah, not on a date. Well, I told you we were going to do this last time. I kind of hinted at it, and we're going to be using some pretty hairy math. Yeah. Copy that guy down.
What do you mean?
All right, now, the math's going to get difficult because instead of being asked for Kc, I'm going to give you Kc and ask you for X. And now, I'm going to do two examples today. The first one is going to be relatively easy. It'll get across the concept, but it's going to be easy because it turns out to be a perfect square, kind of like me. And because it's a perfect square, I don't have to do the quadratic equation. I don't have to do FOIL. I don't have to do all that the difficult algebra stuff and not get lost in the middle of it. It's still going to take up this whole board. It's not going to be it will get across the actual concept. In the past, the lab we just did last week and the problems we did last week, I gave you very similar information. Difference was, instead of saying, hey, here's Kc, tell me what everything is at equilibrium, I said, here's what a guy is at equilibrium, tell me Kc. So that's the difference between this one and the other ones we already did. We even did a lab on it. All right, I'll kind of hint at that as we go along. But this is no easy task. Matter of fact, we're going to spend all of today doing these two examples. And then I'm going to give you a whole half of the period tomorrow. Like, there's a double period, so one of those full periods. It's going to be spent with you guys doing the problems because they do require some practice. There's only going to be 4 problems. Yeah, there's only 4 homework problems, and yet I'm going to give you that whole period to do them because there are some problems with it. And I'm also going to help you use your calculators. How many of you have a graphing calculator in here? All right, well, I'm going to put the program on if it's not already there. Some of them I had to put on. Some of you already have it. It has to be the right quad formula program. I say quad form 5. It has to be the right one because otherwise it rounds off to 2 decimal places, in which case it's no good for our thing. All right, let's get started here. And I'm going to start with some yellow here, I think.
Not black?
We can't use black on here.
All
right, now look, we're going to have to go pretty quickly here for this first one because he's not the difficult one. All right, we have the same way we set up the other ones. We're going to set up this one. ICE, initial, change, and equilibrium. I'm only going to write this down one last time here. I'm not going to write. I'm going to write ICE from now on, not initial, change, and equilibrium. We draw a line, and we start it the same way we started before. You guys remember the same things I warned you about. My initial concentration of A is not 0.4. Why?
Just divide it by 2.
Yeah, divide it by 2, the size of the container, gives me the molarity, 0.200 molar. B is told to be 0.40 moles again. Place it in a 2-liter container. If it's a gas, it fills up the container, 0.200 molar. How much C and D do I have if I just added them? 0, right. Okay. Now, my change, we know how that goes. It mimics the coefficient. So it's minus 1x, plus x, and plus x. The reason, of course, the products increase. I have none of them now. Over time, I'm going to get more products. I have lots of reactants. Over time, that's going to decrease. Okay, so the change mirrors the coefficients. Then finally, the equilibrium at 0.200 minus x. This is exactly what we did in the lab, exactly what we did in the homework problems. I'm leaving out the units here just to go a little bit faster, x and x. All right, so there you have it. This is exactly what I had before at this point. Now, here's what's different. At this point in the homework problem and in the lab, here's what we did in the lab. We put our C, which is iron thiocyanate, into the spec 20. We read how red it was. And the redder it was, the higher the absorbance, the higher the concentration. So we were able to determine X. We were able to figure out what X's are. I gave it to you in the homework problem. Now, that's not going to be the case this time. I'm not giving you X. I'm giving you Kc. So I'm going to ask you for X. So that's what we have to do. So it's okay. We set up the problem the same way. Matter of fact, I'm going to use some different colors trying to keep it straight. But we are going to end up in the next one especially have a lot of crap on here. All right, Kc is going to equal products raised to the coefficients. So C raised to the first power, D raised to the first power over A, B, which is basically the equilibrium expression which we've seen before. I know Kc. All right, what do I know Kc to be? I know Kc to be 97.4, therefore equals, I'm going to plug in everything in terms of x, which would seem to make this a very difficult problem. But there's a little trick to this one that makes it easy. C and D are x and x, so we put x times x. A and B are 0.200 minus x and 0.200 minus x. Now, there's your equation. Everybody see where all that came from. What's different about this is I ain't solving for x. I'm sorry, I ain't solving for Kc. I'm giving Kc. I'm solving for x. And this would be very hard if it weren't, and the next one will be, if it weren't for the fact that this side of the equation, where the x's are, happens to be a perfect square. I can simply take the square root of both sides to do this guy. Notice the numerator is a perfect square. X times x is a perfect square. And the denominator is also a perfect square. This does not happen every time, but it will happen in one or two of the homework problems tonight, and also maybe in one of the problems in the test as well. All right. So because of that, I don't have to FOIL these. I don't have to square binomials or anything like that. All I have to do is plug into my calculator, 97.4. Tell me what's his square root. I need you guys to help me out with these, and more than one person to do it, so we don't, especially the next one, make a mistake. Hurry up. I'm glad to see a lot of graphing calculators. I will be able to put the program on the 93s and the 83s and 84. 83s and 84 to me.
9.89.
So was it 9.89?
I got 9.86.
Is it?
I got 9.86.
All right, well,
That's a 6.
then it's a 6.
Oh my God.
Yes, you see, if it's upside down, it's a 9. Very good,
I
Liz.
throw 69.
It's just a matter of time before I go off on this.
But it rounds up, so it's 9.87. Just so you know.
Is it?
9.86?
All right, whatever.
You want to play?
Equals x over 0.200 minus x. Because I took the square root of both, right? So that's easy enough. All right. Now, what do I do next? What do you think I'm going to do next to solve for x?
Give it up.
Multiply by the reciprocal.
Give up.
Well, it's easy.
X over the 9.
I'm going to cross multiply. You see, I got 9.86, or is it 0.86 or 0.87 really?
It's 0.87 really.
0.87? All right. 9.87 equals x over this. I'm going to cross multiply. So I will get x equals, I distributed 9.87 times 0.2. What do I get there? Do that in the calculator quick. Hurry up.
1.97.
1.97 minus 9.87x. Right? So there I have it. X equals 1.97
Wait,
minus 9.87x.
How'd you get the 1.97?
why isn't the 9.87 over
Oh my
1?
God.
Why did you just multiply straight across?
I did not multiply straight across.
Yes, you did.
No, I did
No,
not.
we didn't.
How'd you get
Okay,
the
Shania.
x?
Shania,
There's an x on the bottom.
I have Shania.
You have to pretend there's a 1 now.
4 equals x over 2. How would you solve that? You would cross multiply.
Yeah.
That's what we did.
I forgot that it was 0.2 minus x.
All
I'm
right.
sorry.
So now, there we go. What are we going to do? Which side are we going to bring the variables to keep them positive? To the left. All right. So we'll bring a positive 9.87 plus 1 would give me what? 10.87x equals what? 1.97, right? So x would equal, those two divided, right? Divide them out, give me x. Everybody agree it's what do you want more significant figure?
181.
181. Everybody agree about that, okay? So 181, that's what x equals. Now I'm almost done, okay? Wait, are you going to clear it? I'm not going to clear it, no. Okay. I'm going to
Oh, my lantern.
use yellow now. Okay, back to yellow. Okay, that was all the work, okay. Well, any questions on the math so far?
I might have a question. I'm still confused on the change.
Well, the change is, it's always going to basically mirror the exponents. That's how much this guy changes by. In the initial started out at 0.2, he's going to go down by some amount x. If I had a 2 here, it would be down by 2x.
Oh, okay.
Over here, it would be, if there's a 3 there, plus 2x or plus 3x or
It's
whatever.
always going to go down.
Well, this guy's going to go down because I put into the container A and B. Which way does it have to go? If I put in the container A and B, I have no C and D, and I wait over time, this guy has to decrease, that guy has to increase, okay? All right, now back,
10.87.
what's that?
How'd you get 10.87?
Where'd I get 10.87?
God, Dave, you're in calculus.
This equation right here, right? X equals 1.97 minus 9.87x. right? I bring the 9.87 over to this side. I get 10.87x equals 1.97. So x equals 1.181. Now, I'm still not done. The reason I want to change the colors here is because I still have one last thing to do. I've got to plug in x for every one of these, right? So basically, C and D are easy. C and D are both going to equal 0.181 molar. Everybody agree? By the way, you can keep going straight down. I have a whiteboard, and I want to show it all on the screen, so I have to do this messy stuff here. You guys just keep going so it doesn't get all confusing. C and D, right, are X. You see it? So C and D are 0.181 molar. What are A and B going to be?
0.200 minus.
Exactly, 0.200 minus 0.181, which would be what? 0.019 molar. Okay, those are your two answers actually. That one there and that one there are your two answers. And you're finally done. Now that one was certainly not what I've been warning you about and scaring you about, because we were able to take the square root of both sides, so it made it a little bit easier. All I had to do was cross multiply and do some basic algebra. And even there, we had two problems with both Lizzie and Dayton. Okay? Well, imagine how it's going to be when we do this next one. Okay? Watch this.
Easy.
Copy this guy down. Okay. Same stuff as before. It's exactly the same kind of information. The difference is, unfortunately, the math is not going to work out to be as easy. Now, we're going to do this one from scratch, and we're going to have to do it all the way through using the quadratic equation and everything. But after I do this one from scratch, I'm going to show you, make sure everybody has a program on the graphing calculators that will help us do at least one step of it easier. Some of you already have it. Others of you don't, maybe have it and don't even know it, and it's, you don't know how to use it. I'll show you how to use it.
Okay. Wow.
Okay, you ready?
No.
Hurry up.
Does it only work on graphing calculators?
Yeah, only on graphing calculators.
I gotta put it here.
Which, by the way, I'll tell you that while you're copying this too. If you don't own a graphing calculator, you absolutely should ask one of the math teachers. There's not that many people I have in this class, and at least half of you already have one. So you're talking about maybe 3 or 4 people per class that will actually need to borrow one, because that way you'll be able to use it at home to do your homework. I have like 7 or 8 to be able to lend you during the class. So tomorrow, you'll have all that period to do it. But you should borrow one so I can put it onto those calculators, and then you won't have to worry about it. You'll have it for any time you need it. Okay, you ready? All right. I'm going to shorten this guy up a little bit. Instead of initial change in equilibrium, just write ICE. Same stuff as before. I'm going to try to fit all this on one board again, just so I can, tape it all. My initial concentration is not 0.6.
Divided by 5.
Divide it by 5. Do that on the calculator quickly. Everybody do it so we don't make a mistake. What is it? 0.12. One more number. Is it 0.120? 0.120 then? Right?
Yeah.
All right. And what's B? B is 0.2 divided by 5 is what? 0.0400 for significant figures. Okay.
You have to keep them.
And finally, my 2C is 0 because I hasn't started reacting yet. Okay. Now, my change.
Negative.
Oh, wait. Hold it.
Yeah.
What's my change going to be here?
Minus.
Minus X here.
Minus.
And over here.
Just
No.
plus 2x.
Plus 2X. That's what I was trying to tell
Okay.
you. Remember, it mirrors the coefficients. That's the change. That is. All right. Now we have 0.120 minus X, 0.0400 minus X, and 2X. Everything's exactly as before. Same as before. I'm going to write my equation down. All right. For the Kc, what is Kc going to equal? Kc will equal products over reactants. I need you to write Kc out. Don't just go right to the x's. It's going to equal C squared, right? Everybody agree? Over what? A times B, both raised to the first power. Now I can plug my numbers in. Kc is told to me 0.0537. I'm going to keep switching back and forth colors so it makes it a little bit easier to keep track of this. 0.0537 equals C, which is 2x, quantity squared over 0.120 minus x times 0.0400 minus x. Got it? All right, so up till now, it's pretty much the same. Here's the problem. I can't just take the square root of both sides. Yes, the numerator is a perfect square. The denominator is not.
No.
So I have to FOIL the denominator, right? Firsts, remember how you do those?
First.
Outer and inners added together,
Yeah.
and then the last. Now, hold on. Before we do that, stop. Don't start doing it. We got to use our heads. Let's take our time. We do it in step by step. That's where we always went wrong in any of the basic algebra. This is the hardest algebra we've had to do so far. So let's switch to green again. What's 2x quantity squared? It's not 2x squared. It's 4x squared. So 4x squared over, by the way, this doesn't change it. It's still 0.0537 equals 4x squared over, now let's FOIL those. What's 0.120 times 0.040? 0.0048. Does everybody get that?
Yeah.
0.00480. All right. What's these two guys? A negative 0.120x and a negative 0.040x is going to get you what? A negative point what? 160x. Is that correct?
Yes.
Everybody see what we're doing? FOIL. First, outer, inner. Now the last. Negative x times negative x is not negative x squared. What is it? It's positive x squared. Okay, because a negative times a negative is a positive. Okay? Very common mistake right there. Is calling that negative. Everybody got that? A negative x times a negative x is a positive x squared.
What you do to get 4x squared?
Where did I get 4x squared?
On the top.
On the top, 2x quantity squared. 2 squared is 4, x squared is x squared. Okay? All right. Now, again, I'm going to change colors one more time here. Probably more than once. What am I going to do now to both sides? Or not to both sides. What am I going to do now?
You got to solve.
Yeah, how? What should I do?
Well, I don't know.
Again, cross multiply, right? Cross multiply.
Sure.
So I'm going to write it up here. I'm going to look at you guys just going straight down, but I have to have room on the board here. I cross multiply. I get 4x squared on the left equals, and now I've got to distribute that 0.0537 across this equation. So 0.0537 times 0.00480. What do we get? Everybody get 0.000258? All right. Distributing 0.0537 times a negative 0.160x, and I get what? A negative what? She got 0.00859?
Yep.
You get that?
Yep.
Everybody? And then I got simply 0.0537 times x squared, which would be a positive 0.0537x squared. There it is. Now, I'm almost there. I want to get this into the form of a quadratic equation. A quadratic equation's form looks like this. Don't write this down, okay? I'm actually going to put a thing in between this. ax squared plus bx plus c equals 0. Remember that? Don't write that down yet. Don't write that down, okay?
Now.
I'm behind right now.
How far behind? I'm going as slow as I possibly can.
What are we doing?
All right, so what am I going to do to this guy? I want to bring the squared functions so that they're positive. Whichever side I'm going to make them positive. Well, I've got a 4x squared over there, and I've got a 0.05x squared over here. So I want to bring them over to that side. Agreed?
Agreed.
That'll give me 3 point what? Do that. 4 minus 0.0537 would be what?
946.
3.9. 5, we'll just call it, right? Because actually this should have been 4.00, which would be right number. 3.95 x squared, okay? I bring this guy over, what does he become? He becomes positive, right? plus 0.00859x. And I bring this guy over, he becomes what? Negative. So minus 0.000258, and the whole thing equals 0. There's your quadratic equation. You should write underneath that ax squared plus bx plus c to indicate that, what each thing is. Okay? There's your a. There's your b. And there's your c. Right?
Yeah, very good.
Wow, that looks good. Now, underneath that, although I'm going to put it up here just to get it out of the way, underneath that, you have to write down the quadratic formula, which is from Mr. Thatcher's class. X equals negative b.
Everybody does.
Squared, b squared, minus 4ac
What the hell? Why are we doing this? This is math.
over 2a. Remember that?
What?
Oh, crap.
What is that supposed to do?
What?
Yeah,
we didn't learn that yet.
You guys never learned the quadratic equation. You would have learned it, guys, back in 8th or 9th grade.
Yeah.
You did not learn it in some advanced class, okay? 9th grade, maybe.
What does that have to do with what we're
Yes,
doing
we
here?
use it all.
Let me show you. Stop. Forget it. Regardless of whether you remember Thatcher or whoever teaching it to you. This is how you solve a quadratic equation. That is, this is a quadratic equation, and that's the formula to solve it. You have to plug in to get x all of the information, where b is the b here, 0.005859. A is this a, that's the coefficient of this guy, and c is the number over there. So I want everyone right now. I'm even going to stop the video because when I put it back on, because it's going to take you a while. Just try plugging this in and solving for x and using this formula right now. Do that. And you get for your x, you get two roots after you plug those in. All right, you get x equals 0.00702. You said
Yeah.
02, and you get x equals. Don't write both of these down. Just watch. X equals what? 0.00 what?
Negative 0.009.
Negative 0.00929. Now, one of these guys doesn't make any sense. All right. Now, let me show you first of all why you get to and what's going on here. What is this an equation for? What shape would it be if you were to have graphed it? What shape would it be? A parabola, right. Now, let's take a look at that. So basically, here's your coordinates, your x and y axis. And so if I have a parabola, I basically have, and I draw a line, it intersects at two places, one positive and one negative. In math class, that's not a problem, okay? Oh, and by the way, not every parabola has to be like that. Some parabolas might be entirely in the positive coordinates. So when you draw a line where it intersects, you'll get two positive answers. You got to be able to figure out which one makes sense, which one doesn't. But it's easy to tell in this case which one doesn't make sense in reality. See, math has no problem with this. Math has no problem with negative numbers. We do. Is there any such thing? Did I erase the whole thing? I couldn't. I shouldn't have. All right, there we go. Is that the wrong one though, right?
Yeah.
Okay, hold on. That's one. All right. Look at it. What? There we go. Okay. Now look at it. So which of these two makes no sense in terms of chemistry? They both make sense in terms of that equation. They're both correct. All right. But in terms of chemistry, what you're saying if you have a negative answer is that you put in A and B into the container with no C. You left it sit there. Over time, you got even more A and B. And you got a negative amount of C. Of course, that doesn't make any sense. So I know to ignore this guy and just use that one. Okay?
Sounds great.
Yeah.
All right.
Now, what do we do with that number? Last thing to do here.
Plug it in.
We're going to plug that x in back to the three answers. So for A, it's going to be 0.120 minus x. So it's 0.120 minus 0.00702. That'll give you one answer. For B, it's going to be 0.0400 minus 0.00702. That'll give you your B answer. And for C, it's simply going to be 2 times 0.00702. And that'll give you your answer for C. Okay, so what do you get for A? For 1, 2 minus that. that right?
Yeah.
0.113 molar. Okay, what about B?
I rounded off first, but
0.0329.
0.0329.
it says 8 after that. Doesn't matter.
I don't.
3.
And lastly?
0.01404.
Okay.
Are
So
the
there.
units always molar?
You're finding a concentration, so your units are going to be molar. That is impressive. Okay, I hope you all got that. Now the nice part, what I'm about to do, I'll show you after I shut the thing off, is you no longer will have to do this part. Okay, I'm going to show you a program right now.